Hello and welcome to this episode of Depth++. Today we are going to talk about the standard input, output and error. Stay with us. To start our discussion, we are going to have a look at the simple Hello World program. And the first thing that we want to do is intermixing this with C code. So for example, I'm going to print Hello World with use of stout and printf and see what will happen. So this is the code, and if I run this, you can see that Hello World is printed. However, if I set the sync with the stdio function to false, it means that C++ internal buffering doesn't sync itself with C buffering. And if I run code now, you can see that the order of words are reversed. So that's one thing to have in mind. Now let's head to C++11 draft and see what we can learn from there. Now we can see that cin controls input from a stream buffer associated with object stdin. Cout controls output associated with stdout, and cr and clog control output to a stream buffer associated with object stderr. So we have 4 objects for 3 different streams, and these streams are just ways for OS here Linux to provide input and output to and from our application. Now in number 2, we have after the object cin is initialized, the entire returns reference to cout. Now we know that in most implementations, cout is buffered, and that's because performance enhancement. And for example, consider that we want to take input from the user, for example, ask for the name. We want the question to be shown on the screen first, and then we want to wait for the answer. So for example, in this code, we know that enter name is first shown, and then we wait for user to enter cname. However, if I untie cin from ctie, which means that I can tie cin to null ptr, for example, and I run the code, you can see that we are waiting for the input before actually showing the output. So time means that because cout is buffered in most implementation and the flush time is undeterministic, whenever we want to make sure something like this does not happen, we tie these two together, and that means any operation on the tied stream will cause the first stream to flush, and that means that we can be sure that the order is reserved. So here it is. So let's head back to draft and see what we can see from here again. So number 5 says after the object cr is initialized, cr flags and unit buff is on 0, and cr.tie returns reference to cout. So cr also is tied to cout, so we can tie two output streams together also. And if we search for this, we can see that it means that it flushes output after each output operation. So basically, a standard says that cr must flush output after each operation, and that means that if we use cr, we get lower speed. However, we can be sure that our output is delivered to the output device as fast as possible. So an example when this matters can be this. So suppose that we have a recursive function with no exit situation. Now if I run this code, we get a Stack Overflow, but we have no output. However, if I use cr in this situation, you can see that before the segmentation fault, the output message is printed. So with the aid of cr, we can make sure that our output is delivered to the output device as fast as possible. Now, another thing that difference between cr and cout is when, for example, I use quick exit. If I use quick exit here, you can see that with cr we have the output message. However, if I use cout, there's nothing show here. And since we know that cr and cout are typed together, so if I use it here and I run code again, you can see that cout is also flushed because cr is tied to that, and we had an operation on the cr, so the output of the cout is flushed also. Now, another thing that we can point to is that we want to use cout and cr really for different purposes. So we want to put our output, our normal outputs with cout, and error and debugging messages with cr. And why is that? Is because that with the aid of, for example, redirection, we can do things like this. So let's say that I want to keep the normal output, but just print all the error messages inside the file. So I can do something like this very easily. So you can say here is printed here. However, a file named err is created here with all the cr error messages. Another thing that we can do here, for example, is that I found this code on the internet that helps me to make the color of CR to red, for example. So these are why we should use these different output streams for different purposes in our code. So another thing that I want to mention is that in Linux, um, everything is file, and we can just bypass this use of IO stream and directly manipulate the standard input or output or error with just file manipulation. So for example, if we use this code, the effect is that is outputting, for example, hello with stdout. So if I run this code, you can see that hello is printed, and the file descriptor number is 0 for a standard input, 1 for a standard output, and 2 for a standard error, and that's pretty much the standard. And that's it for today. I hope you enjoyed this episode.